This is question 21 of the chapter 3 review. We have a bullet fired into a ballistic pendulum. There's our bullet. And it deflects the pendulum by 12 degrees. This allows us to figure out what the change in height is, because this angle up here, the 12 degrees, is the same as the angle down below here. If I want to know, this is also 12 degrees. So if I know 12 degrees and I know the length of the pendulum, I can figure out the change in height. It works out to delta H being equal to 0.022 meters. Then I can simply say that I know the kinetic energy of the bullet once it has entered the block is equal to the potential energy mg delta H once it has reached the maximum height. Now you have to be very careful here. The momentum is conserved, but the potential energy that results here is only due to the kinetic energy that the bullet and block have once the bullet has entered the block. The kinetic energy of that bullet is not conserved. This is an inelastic collision, so we cannot simply say I know what the kinetic energy of the bullet was based on the maximum height of the ballistic pendulum. mv squared over 2, we're told the mass of the block at the bottom. We can ignore the bullet. So when we do mv squared here, this m is not the bullet, remember, it is the mass of the block. So 6 times v squared over 2, we'll set it up this way, is equal to 6, the mass of the block, times 9.8 times the change in height. Rearrangement gives us a velocity of 0.66 meters per second. And now this is where I can use the fact that momentum 1 is equal to momentum 2. Like this. So now I know this is the momentum or the velocity of the block. So the mass of the block, 6 kilograms, times the velocity of the block, 0.66, is equal to the mass of that bullet, which is 0.005 kilos, times its velocity. Solving for velocity here, we get 788 meters per second. That's the velocity of the bullet.